Okay, recap. Yesterday, we have gone through a few law of indexes, right? The first one, if you take the same base with a different power, m multiply n, the first one is you add the power component. Okay. Second one is division. If you have the same base and different power, you minus the power component. The third one, if your exponential power is 0, means you will get 1 as the final answer. And if you need to find the reciprocal, which is you will have the power of minus m, reciprocal. And you have a combination of power of m divided by n, means you power the m and then you root the n. Okay, so we have gone through all this. And yesterday we have also gone through exercise 1 to 5. 6 to 10, you did it in your homework. Okay, so today, just to further review what you have learned yesterday. So can you evaluate this question? 3 power 3 multiplied 5 power 7 divided by 5 power 3 and 3 power 4. So yesterday we are quite base. We have the same base. Now we have a different base combined in the same division. So how do we solve this kind of question? You split the denominator. Can you do that? Can you split denominator like that? This is power. Okay. So the basic rules down here is to put everything in the same base. The same base. So you group them. So you group the same base together. You group them together first, means you put the same base 3, 3 and 4. Then you pull the base 5 together. Okay. So this is indexes. Next week we're going to later second session you will see logarithm log. Right. So here you can do already 3 divided by 3 power 3 divided by 3 power 4 is 3 power minus 1, and the second one is 5 power 4. So for this module, for this subject, you need to show me the steps, because it's chapter 4. We work on indexes. So you need to show me the skill in law of indexes. All right. Then you put them together and you calculate the value. So 3 minus 1 is actually what? Reciprocal is 1 over 3. So the final answer is you can stop at 625 divided by 3, or in some module, some subject, you need to put in round number 208 1 over 3. So this is another one, which you see base of 2, base of 3, and base of 7. So same principle that we use, means we group the base together. So means you have 3 groups, with the group number 1 is 2, number 2 is 3, and 7. Okay, then you work with the index. If it's multiplication, means you add the power. If it's divide, means you minus the index. Okay, so just by your mind calculation, what will be your base 2 answer? 2 power what at the end? Okay, -1. So 3 will be 3 power 2. 7 will be power 0 but equal to 1. Okay. So your final answer will be 9 divided by 2. Okay. Again, in the test, you need to show me the steps by applying the law of indexes. Okay. So this one is just by just a quick question. So I will skip this one. It's just the conversion of the reminder that if you cube something, you have 2 answers. You have plus and minus. It's just a reminder of the cube, right? So the final answer, you have plus minus. Just to remember to put the plus minus sign in your answer. Okay. So same as B lah. B, you need to put the index into the fourth root. Then in the end, you still get plus minus power 3. So it's plus minus 8. Yeah. So in the previous, maybe your SPM level, you stop at positive number. But when you go into university degree level, you have positive negative side of number. Okay. So it depends on module that you study. In static, positive means along the axis. Negative means opposite the axis. Okay. C also the same. C also you have to have plus minus. But plus minus, why there's no need? Because you square it. So no matter how you square, you still get positive number. Okay. Yeah, correct. Yeah, correct. So this just to show you, be careful when you have the square answer. Okay, so this one will be a more, it look complex, but actually it's just a decimal place, right? So that if you see decimal place, like for example 1.5, the strategy is to change it into fraction number. 1.5 is, yeah, you change into fraction number. Okay, 3/2. Then you can work with the principle, right? The law of indexes. Yeah, the rest is still the same of application of all the laws of indexes. All right, okay. So this one, the one that you see on the screen here means we work one by one first. We pull out the number and then we work one by one as a side note. Then we substitute back the value. Yeah. So okay, this example, no question. So we move on. So I give you another set of answer also, but still they are showing the law of indexes. Okay, so this one, just to be careful when you have just now the earlier example is there's no addition marks here. So if you see addition mark, you need to be careful a bit. Just now it's all the multiplication on the top and multiplication and below. So if you have addition marks in the center, you need to break into 2 different groups. Okay. So here, you divide each term by the highest common factor. Like for example, this one. So if you see a different denominator, what you do, you take, for example, in here, the base 3 power 2 and base 3 power 4, you take the common, highest common. So you take 3 power 4 and not 3 power 2 as a common factor, right? So you have 5, base 5, you have 5 power 5 and 5 power 4, you take the highest, means 5 power, 5 power 3. 3 power 2 and 5 power 3. Okay, so we take the highest common factor, or in other case, you take the minimum, the same factor, the same factor. So here is 3 power 2 and 5 power 3. Okay. So here you all of the component here you divide by the same denominator. So you will simplify the equation. So here, like how you get 3 power 2 minus 2. 3 power 2 divided by 3 power 2 means 2 minus 2. Then this is 5, base 5 power 5 minus 3. And then be careful on the addition. You need to break the addition. Then continue with the multiplication process. 3 power 3 minus 2, base 5, 3 minus 3, and the bottom also same. You work with the same base first, 4 minus 2, and same base 5, 4 minus 3. And then you do the analysis. You move on. Yeah. So at the end, you get 28 over 45. Okay, by the end of the session, I'll give you one application question in aerospace engineering, how these indexes apply. Okay, so this one, you go home and see if you don't understand this one. It's actually the same working steps. It's only just need to highlight if you see any additional process on the top or bottom, you use the highest common factor to remove or to simplify the equation. Yeah. So just observe. So what is the lowest common factor for base 3? 3 power 2. So 5 here, 3 power 3. Okay. So then the rest is just normal process lah. Okay. So the answer for this example is 25 over 48. Is it the same question? Okay, so this is another, it looks complex, but actually it's the same concept. You expand the equation first, right? Means you expand the bracket first. Put the 3 inside the base. Then only you do the working step like the previous one. Okay. So this is just the some reminder lah. If you see bracket, you expand the bracket first. You observe the step. So this is I do it one by one. So I take 3 over 5 minus 2, means I remove the negative sign power first. So here I remove the minus 2, so I convert into reciprocal format. Reciprocal, then you eliminate the bracket, the bracket. Then you put it in the more simpler form in positive indexes. Right? You do the same for the rest, like another one denominator with a -3 power -3, also the same. So it's actually a flip. If you want to remove the negative, you flip the number inside the bracket. Because it's 1 minus some 1 divide something. So actually you flip the number. Yeah. So the rest is like the same, the previous example. Right. You find the lowest, the rest is, yeah. So you try to observe. So this is your exercise. So today we won't do this one. So you go home and do for the 1 hour after this class, right? So this is a reminder of some of the important. So there are 8 questions. So you go home and practice later, right? Okay. So we go into log a little bit. Then I give you one small exercise. Then we call it a day. Okay. All right. So why we need to study log? Because in some of the experiment data, you are unable to have a linear data. Linear data means you input 1, you get 1. You input 2, you get. It means it's scalable in y equal to mx plus c. All right. So logarithma, for example, you have some exponential graph. For example, the prices for AirAsia ticket, right? AirAsia ticket is in exponential graph. It just give you 1 or 2 low ticket, but actually, if you your number of customers increase, actually the ticket price increase. So it's actually one of the marketing strategy. It will sound expensive, but if you are the latecomers, you are actually buying expensive ticket. Okay. So some of the application that you see in later on, if you in my foundation chemistry class, you will be using logarithm to find the pH value. In chemistry 2 lah, in foundation, right? So you have log and radiative decay. This one in some of the module, especially corrosion module, right? Earthquake, right? Earthquake also use log application. So ratchet scale, they're actually in scale. So detail how earthquake use log, that one later. It's not the main thing, but important that you aware that there is an application of log in daily life. Okay. Yeah, some lah, light intensity and all this. Okay, sound, your headphone, decibel, all these are also in log scale. So they actually potential meters. You input the gain, the sound. You turn up the volume. They're actually in the log scale. Yeah. Is log actually solving non-linear relationship? Okay, non-linear. Okay, so just recap. Previously, we learned indexes, right? Indexes. So 16 equal to 2 power 4. So we can write in the log form base 2. You can convert 16 equal to log 2, 16 equal 4. It's just a conversion from indexes into log form. Okay. So the first equation for log is this one. If we have y equal to ax, y equal to a function of y equal to exponential equation, you can convert that exponential in the log form. Means x equal to log y. This one is actually a linear form. Right? You actually changing this log form, y equal to ax. This kind of graph into linear graph, y equal to mx plus c. Because this is the form in the full number. The full number can say as a full number. Yeah. So yeah. So this is just some application. So if y equal to a power x, you can write x equal to log base a y. Okay. Application of this one will be in aerodynamics, in your wind tunnel experiment, some flight dynamics, control theory, and all this. Yeah. So if you have 64 equal to 8 power 2, if you want to write in the base of 8, it will be log 8, 64 equal to. Yes. Yeah, you will have different, but the concept is actually you're converting a non-linear graph into linear graph. So this is another example. If you can convert log base 327 to equal 3 into indexes form. So if you see a log base 327 equal 3, can you write in the indexes form? Equal 3 power 3. 3 power 3 equal 27. Yeah. Okay. Okay, this is a common log. Common log means base 10. Common log means base 10. 1000 equal to 10 power 3. You can write 3 equal to log base 10, 1000. Okay, so sometimes we just short form in LG, log equal to LG. Okay, so you can, some calculator, you have LG sign, you can just press log 27.5, you'll get 1.4939 something. Okay. Okay. Yeah. Okay. So another one is called, you will see a ln, or in some textbook they call it Neperian log or natural log. So we have a common log and natural log. So it means ln or log power log base e. Means in your calculator you see a small e in your button there. It's a natural log. So 1e is equal to 2.71 something lah. Okay, so this one basically where you use the small e, especially electronic. The electron moving, then the power come out, move orbit for one and orbit. The plasma will come out, X-ray and all this. So this one is more on the molecular energy or quantum physics lah. I'll call it quantum physics. All right. Okay, so this is just a very simple exercise. So it asks you to evaluate log base 3 of 9. So you can actually write in the index form, right? So you convert log 39 equal to 3 power x, because you don't know x, right? Equal 9. So you can convert the 9 into the same base of 3. Your x will be 2. Yeah. Important is you know how to convert the log into indexes, from indexes into log. Because sometimes it's more easier you see data in log. Some case you more easier to see in exponential power data. So you write like this. So you write x equal to log something. then you convert the log base into indexes format. Then you put side by side. You are comparing the power. You write x equal to. Yeah. So this is just a basic concept. You won't see this kind of question in the real test or application. You'll see a longer question. Okay. Yes. Okay, log 10 equal 1. This one you should know lah. Yeah. So the final answer is you write log 10 equal 1. Means that from this observation you have the same base, same same base with the same exponential. Not exponential, same the term already, but never mind. This is the thing. Right. Log 16.8, what is the x? Log 16.8, you can write in x equal to log 16.8, then change the 16x equal to 8, then how? So you need to explain a bit. You see this kind of question in test or final exam. You won't see the previous one. Previous one is too direct. That one is at certificate level. Degree level, you need to look at the number, then you need to break into more simpler form. 16 to the power. So you break the same factor. Usually you use power base 2, 3, 2, 3, and we call it primary number. Usually primary number. Right, 2, 3, 7, 9, something. Okay. So you break into 2. I think the rest step you can go already.
Secondary school 我们是这样写的，这边 two four， 这边 two three，所以出来这样子。
也可以啊，也可以。Okay. The one that you see here is actually to link back what you learned in previous class, indexes. How you convert index into log and log to index. Okay. So you continue. So you can find the x. X is 3/4. Okay. So in the test, you don't need to write the law of indexes. No need. Straight away, give me what is x. Okay. Is it correct? Sorry, my PowerPoint slides got wrong. It should be. The answer is 3/4. Okay. 3/4. Some error in my typo here. Okay. Log 0.001, what is the x? LG is base 10, right? Base 10. So 0.001 is 10 power negative how many? 3, yeah? It's got 3 decimal. So you move to the front, 3 times, means you divide 1000. Divide 1000 means it's minus 3. Okay, so you don't know something, so you write x equal to log 0.001. Okay, so you know that, so this is just to tell you that 0.01 is 10 power negative 3 lah. Okay, I should space this one. My slide, I have to space this one, move down. Right. So this one, log 0.001, your answer is equal minus 3. What about natural? Ln. Ln is 1. Why? Ln is what? Log EE. Log EE, if you have the same base and the same answer, equal 1. Like, for example, log 10, 10 is 1. Log 100, 100 is 1. Okay? So you write x equal to ln E. You can write in the log EE. So it's basically is 1. Yes, it's a positive side. Okay. Okay, so this another form. So base 3, 81. How is 3 multiply something equal to 81? 4. 4. So but it's a reciprocal, so it's minus 4. Power negative 4. But still same, the step, you start with x equals something. X equals something, then you convert into indexes. Right? Log 3 means base 3. So 3 power x equal to 1 over 81. So we always like to remove the reciprocal sign or factorial sign into positive number. So you will get 3 power something, 3 power negative 4. So if you're fast, you don't need to show me 1 over 3 power 4. You can straight away write 3 negative 4. So x equal minus 4. Okay. So you always need to give me what is the final answer. You need to conclude your answer. Always don't stop at x minus 4 and then expect me to understand what you're trying to do. You always need to copy back the question and equal what. Yeah. So the rest, I'll just keep lah. You go home and have a look. If you have any question, you come back to me. Okay. Okay, so this will be the exercise. So we see how. If you have time, we do. If no time, then this is your homework for the 1 hour after this. Okay, we stop here, and I give you one case study.